Hi guys, welcome back to the Art of Server and welcome back to part 2 of the R810 storage upgrade series. So in the last video, I showed you guys how to upgrade the R820 from a RAID controller to an IT mode HBA controller. And so now we have a bunch of SSDs in here with an IT mode 9207 8i controller so that this machine can be ready for something like ZFS or Proxmox with ZFS. So in today's video, I'm going to take this upgrade path up one more notch. And one of the things that I want to share with you guys that's kind of a little bit of a trick of the trade is that when you have a direct attached backplane, so this backplane here is an 8-bay backplane and there are 2 cable connections that go into the back of this thing, as you saw in the last video. That means that every SAS lane in those cables is directly connected to each of these ports. And so there really is no SAS expander or anything that is kind of in between the cable and the SAS ports here. And so these are what we call a direct attached backplane. And with direct attached backplanes, the SAS ports are essentially, or the whole backplane itself is essentially like an extension of the cable. And so when you have a backplane of this type, one of the tricks is that you can actually upgrade this. And remember, this is a 12th generation Dell server, and at the time, basically all the SAS hardware was, at SAS-2 level, which is 6 gigabit per second. It was afterwards that SAS-3 came out and was adopted in like the 13th generation and above Dell servers. And so we can actually, because this is a direct attached backplane, we can actually upgrade the hardware to SAS-3 and it will connect at SAS-3 speeds, even though officially this is SAS-2 hardware. Because of the nature of it being direct attached, if I swap out the IT mode controller, the one that we installed last time, which is the 9207-8i, with this one, which is basically a 9300-8i, this is a SAS-3 controller. If I swap out that controller with this, and I swap out the SSDs, which I actually already did, these are not the SSDs that we installed in the last video. I've already installed the rest of them, but this is the first one I just kind of took out to show you guys. But I have these Hitachi SAS-3 SSDs. These are HP labeled ones, but they're basically the same thing as the Hitachi ones. These are SAS-3 SSDs, and if I use this SSD and this SAS controller, the SAS-3 controller, and connect everything up. Now, of course, the SAS-3 controller has a different type of SAS connector. It has an SFF 8643 connector instead of the SFF 8087, and so that's why I have this cable here that basically will connect this backplane to a SFF 8643 connection. And so with this cable, this controller, and these SSDs, I can basically upgrade this generation of server to accept SAS-3 hardware and benefit from the speeds of SAS-3. Okay, so that's what we're going to do today. I'm going to show you how to go about that. Now, one thing to make note of, this only works with direct attached backplanes. So if you have a expander backplane, so on this generation of servers, there's another backplane that's a 16-bay backplane. And if you have 16 bays and you only have 2 SAS cables connecting into that backplane, then for sure that backplane has an expander, because the 2 cables only provide 8 SAS lanes. So there's no way that it can drive 16 drives with just 8 SAS lanes. And so the only way to do that is to have a SAS expander. So if you have a SAS expander, unfortunately this upgrade will not work. So that's because the SAS expander is likely a SAS-2 expander, and so when it's connecting to the HBA, it's going to negotiate down to SAS-2 speeds, and likewise when these SSDs talk to the SAS-2 expander, it's going to negotiate down to SAS-2 speeds. So this does not work for a expander backplane, but if you have a direct attached backplane, this is totally possible. Now, one thing to note, just because you have 16 bays doesn't automatically mean that you have a SAS expander backplane. You need to actually look at the backplane itself, because sometimes what happens is someone will start with 8 bays and then they add another 8 bay in this second hard drive base slot. And when they do that, sometimes they'll add another direct attached backplane, and so they'll have a total of 4 SAS connections on the backplane, so 2 on this side and 2 on this side. In that case, you still have a direct attached backplane, and so you can still perform this type of upgrade to SAS-3. It's just the ones with the SAS expander where this upgrade will not work. Now, as I had mentioned in the previous video, this particular upgrade and some of the other upgrades I'm going to show in the series will also apply to the R720. And this particular one does apply to the R720. The R720 also has a 8-bay version, a 16-bay version, and also a 24-bay version. Now, the 24-bay version, which is the R720 XD, does have an expander. And so in that case, you won't be able to do this type of upgrade. So this only applies to 8-bay versions or 16-bay versions where you have two direct attached backplanes. All right, so with that out of the way, let's go ahead and open up this guy and let me show you how to go ahead and update or upgrade this whole storage subsystem to SAS-3 speeds. All right, guys, welcome back to the inside of the R820. First, before I get started, let me remove the second motherboard because we're gonna have to switch out some cables. So let me just go ahead and do that first. Also, the cable is gonna run past the fan wall, so I'm gonna remove that as well. All right, so with that out of the way, we can see the layout of the entire system here. As before, the SAS cables go to the backplane. As you can see, there are two connectors over here, each one carrying 4 SAS lanes, so a total of 8 SAS lanes to the 8 bays in that backplane. Goes around here and goes into the 9207-8i card that we installed last time. So let's go ahead and just remove all this stuff because we're going to be replacing the cabling and the card this time. And as I mentioned in the last video, usually I find it easier to remove the card first and then remove the SAS cables, as it's really hard to reach under here. And when you're installing a card, it's also usually better to do the reverse of installing the cables first and then installing the card. All right, so let me go ahead and just take these cables out of the way. So when we're upgrading this to SAS-3, the problem is that most SAS-3 controllers do not accept SFF8087. That's not universally true, but the vast majority of SAS-3 controllers use a 8643 connector, so we're not going to be able to use these cables for this upgrade. All right, so instead we have these cables, and this is a 8087 on this side, which is going to go to the backplane. And it has a 8643 on this side, which is going to go into the HBA controller. So now these are not Dell factory cables, obviously, but you don't really need anything special. You just need roughly the right length. And I found these cables in my bin that I think should work. I took some measurements, so I'm pretty sure they're going to work. I'm going to fit them under the little cable tie there and also in there, and just route it along the wall in this cable channel. So when I'm done with this, I'm going to put these cables into this cable channel, but right now, because I'm going to install the cables to the card before I install the card, I'm just going to leave this kind of loose, and then I'll adjust that a little bit later. All right, now the key ingredient to this upgrade, of course, is that HBA that I had mentioned earlier, and that is this guy. So this is also a Dell part number, by the way. So here, let me bring it into the camera. This is a Dell WFN6R. This is essentially a LSI 9300-8i. I believe it follows a reference design. There's really nothing special about it. It's labeled 9341-8i, but this has the IT mode firmware on it, and I guess it's a Dell part, so it has a Dell sticker on it as well. But hardware wise, it's identical to a 9300-8i. It has the IT mode, I believe P16 version of the firmware, and so we're going to use this to drive that backplane. Now, one thing I want to kind of share with you guys, because I've done this type of setup before, some of you might be tempted to use a HBA 330 or H330 flash with IT mode firmware. And I've shown you guys how to do that flash in another video, maybe like a month or two ago. You might be thinking, hey, that's a official Dell HBA, so why don't I just use that? Well, the problem with that is that it doesn't really work with this particular upgrade, because this was not originally designed for that HBA, the H330 card. And the H330 card does a signal check with the backplane. And so it checks from where you connect it, it checks the signal to the backplane to make sure that everything is running correctly. And whatever signal that is, I don't really know the details, whatever signal that is, it doesn't work with this backplane. And so you'll end up getting a fault warning amber light, and you can ignore it. It's really just a cosmetic warning. But if that bothers you, then I recommend going with this card instead, and that warning will not appear. Okay, so to use the H330 backplane successfully, I think you're going to have to also upgrade, the H330 HBA successfully. I mean, you're going to also have to upgrade the backplane to one that was meant for that particular model. So you could probably take the backplane from a Dell R720 perhaps and swap it in here, and then that might work. I haven't actually tried that, by the way, but I suspect that's what's happening, because I have tried the H330 in here with IT mode, and it doesn't really like the cable signaling, and it thinks that there's something disconnected on the backplane. So anyway, I just want to share that with you guys. But this card, I'm pretty sure, will not have that problem, and so that's what we're going to go with. All right, so let me just open this guy up. And as I've said before, I'm going to attach the cables first. Okay, and then I'm going to go in. All right. This is a relatively short card, so we're not going to worry about sliding the PCB into that plastic notch that I had mentioned in the last video. All right, I'll secure the bracket that secures the PCIe bracket, and I'm just going to adjust these cables a little bit to maybe relieve a little bit of strain, because there is kind of a tight angle right here, but otherwise I think it's quite fine. All right, so everything is connected properly. I'm just going to tuck these cables into the cable channel a little bit better, make sure everything is good, and let me put everything back together and put the fan wall in, put the upper motherboard in, and we will have completed our SAS-3 upgrade of the R820. And like I said earlier, this also applies to the R720, and so long as you have the right backplanes that can do this. All right, so let me go get the other parts. All right, so everything's bubbled together. I'm going to go ahead and power this guy on now, and we'll log in on the virtual console terminal and take a look to see that we have this controller, and we're going to see the SSDs, the SAS-3 SSDs, and I'm also going to verify that we're linking at SAS-3 speeds. And then afterwards, we'll kind of run the same benchmarks that we ran in the last video with this setup, and just to see and contrast and compare what this type of upgrade will net us. So anyway, if you guys are interested in this upgrade, I do have this HBA card in my store, and I'll leave a link down in the video description to that. Also, I may carry these cables. I don't know yet. I have to figure out where I can source them, but once I have them available in my store, I'll also create a link in the video description for you to find these cables. So, all right guys, so I'm logged into the R820 via SSH on these three terminals. On the upper right side, I have I/O stats, so you can see the I/O activity on each of the drives. On the bottom right side, I have top running, so we can kind of just see general system utilization. And then on the left side is a terminal where I will be running the benchmarks and running various other commands. So just as I did in the last video, I booted this machine up with mem equals 8G. And that's just because this machine has 1.5 terabytes of RAM. And I don't want any of that RAM interfering with our benchmarks and potentially enhancing performance due to caching and stuff like that. So if you look at LSMem, you'll see that it sees online memory of 7G. So anyway, less than 8. So very little RAM in the system. So hopefully that's not going to affect our benchmarks or kind of skew our benchmarks. All right, so first thing, let's just verify that we have the HBA here. And so you can see that this is a SAS 3008 controller. And if I run lsscsi, you'll see that I have these 8 HGST drives, and the model number is a little bit off because I think that's the model number given by the HP firmware that's on these Hitachi SAS-3 SSDs. But let's just take a quick look at one of them. So I'm just going to pick the first one, the SDC. And you can see that it is a 800 gigabyte SSD with 4K sectors. And right here, okay, negotiated logical link rate 12 gigabit per second. So as I said, as long as you have a direct attached backplane, you can put in a SAS-3 controller with SAS-3 SSDs and you will link at SAS-3 speeds. So let's go ahead and run some benchmarks on this to see what kind of performance enhancements we can see from doing this type of upgrade. All right, so just as I did in the last video, I'm going to be running this through 3 different types of setups. We're going to benchmark a single drive, and we're going to benchmark a RAID-0 across all 8 drives, and then we're going to benchmark a ZFS RAIDZ2 across those 8 drives. And for each of those setups, we're going to run a series of tests, which I will record in this spreadsheet. So this was this first tab here. This was the results from the last video using the 2308 LSI HBA. And today we're going to record on this tab, which is for the, well, I got to change the title there. Well, actually, no, I shouldn't change the title. I think I'm just going to say R820 IO benchmarks. Okay. All right. So this tab will be for the 3008, and this tab was the results from the last benchmark run. So as we did in the last benchmark run in that last video, I'm going to be running a very simple DD sequential write, DD sequential read, and that's just going to give us a ballpark number. Like I said previously, don't take these numbers too seriously. DD is really not a great benchmark, and it's just there to kind of just, see if everything kind of makes sense. All right, so, and then we're going to run a more serious benchmark with IOZone, doing a 1 megabyte record size sequential read, or sequential write, sequential read, random write, random read. And then finally, we're going to repeat those IOZone tests with smaller block size of 4K. So we're going to do a sequential write 4K, sequential read 4K, random write and read in 4K. Now, as you recall from the last video, these two blocks right here. So when we do random read and writes at 4K, because we're not doing any kind of tuning here, because I just, you can do all sorts of tuning to skew your results in favor of one scenario over another, right? So I just want to go with defaults and just to kind of get an idea of what you can get. And of course, if you have a more specialized IO pattern use case that you're targeting for, you can always tune these things to kind of favor that particular pattern that you are using. So anyway, with the default ZFS's RAIDZ2 uses 128K record sizes, and so we know that by running random 4K benchmarks on that, it basically is the worst case scenario where we have a lot of read, modify, write amplification, where basically we're modifying a tiny bit of a 128K record, so we have to read the rest of the record out, modify it, then write it back in. And so those benchmarks are obviously going to be really, really bad. And if you recall here, I'll go back to the previous spreadsheet. You can see here that the numbers are just extremely slow. And so for today's test, I'm actually going to skip that test. So we're going to skip these two just because one, it's very time consuming. I don't think it really adds a lot of value. I think we know the performance is going to be really bad just because of the mismatch of the record size of the benchmark versus the record size of the ZFS pool. So I just, find no reason to do that if we already know that what the results are basically going to be in terms of that it's going to be horrible. And then the other thing is when we ran that test last time, it put a lot of wear on these SSDs unnecessarily for, I think for very little value of what we got out of it. So I'm just going to skip that. We know the results are going to be bad just due to the mismatch of the record size on the benchmark versus the record size in the ZFS pool. So to save my SSDs from too much wear and to save some time in this video, I'm just going to skip this particular test set. Okay. So, all right. So first thing is let's pick a SSD. I'll go with SDC, and let's go ahead and just partition this up. Okay, I'll make a GPT label on this, and let's make a partition. All right, so we should see this now. Yes, SDC1. And so we'll go ahead and make a file system on that. All right, file system is created. Let's go ahead and mount SDC/data. And our first test will be, to run a DD test. So we'll do DD status equal progress. And we'll read in a bunch of zeros, and we will write to this area to a file called speed test. And I will start with 1 megabyte blocks, and we'll do about 10,000 of them. So this is going to basically write about 10 gigabytes of data. And I'm going to use the O flag direct to enable direct IO. And yeah, let's go ahead and do this. All right, so before I run the sequential DD read test, I'm going to drop all cache. And although we ran this with direct IO, so this is probably not necessary, but just as a extra precaution. All right, so we're going to read in that file. We're going to write it to dev null with 1 megabyte block sizes. All right, let's see how this goes. All right, so we got 667 megabytes per second on writes, 605 megabytes per second on reads. So yeah, this is a little bit unexpected. I'm not really sure why the sequential reads are a little bit slower, but again, this is DD, so I'm not going to worry about it too much, but we will go ahead and record this information here. All right, so if you compare this to the last time with the SAS-2 SSDs, you can clearly see that we have a performance advantage just by the fact that we are going with SAS-3. Sequential writes went from 470 to 667, and so with the SAS-3 capable SSDs and the SAS-3 controller, we're basically able to get a little bit more performance out of that drive bay. All right, so next thing is let's go ahead and run the IO zone tests. All right, so as I did in the previous video, I'll just kind of explain this really quick. We're running 32 threads here because we have 32 cores on this system. And so I'm just going to max out the cores. And because we have 32 threads, we're just going to give each thread a 256 megabyte data file. And so in total, that should create about a quarter of 32 would be 8. So about 8 gigabytes total data set that we're working with. We're going to use 1 megabyte record sizes, and we're going to run the 0 test, which is the sequential writes, and the number 1 test is sequential reads. and then number 2 test will give us both the random reads and writes. And we're also going to record the CPU utilization. That's what the dash plus U means. And then the dash I will make sure that we use a direct IO, just as we did in the DD test. All right, so let's go ahead and run this and see what kind of performance we get out of this single SSD. All right, so the test is done. So I'm going to go ahead and record. All right, next up, we're going to rerun this test using 4K block sizes or record sizes and just repeat the same exact test. All right, 4K tests are done. Let's record these results. All right, so we're done testing the single SSD under all the test cases that we were going to test for. And let's take a quick look at this. Let's just look at the IO zone results. We have 649 megabytes per second sequential writes in 1 megabyte blocks, about 986 sequential megabytes per second sequential read with 1 megabyte blocks, 1 megabyte random writes at 656, 1 megabyte random reads at 1037, so almost over a gigabyte per second. And with the 4K results, we have sequential writes 4K at 440, sequential reads at 566, and random writes at 414, random reads at 557. So let's see how that compares with the SAS-2 drive that we saw last time. So clearly we are exceeding the SAS-2 performance across the board. As you can see, yeah, so there's definitely a performance advantage in upgrading to the SAS-3 capable SSDs and SAS-3 controller. And in particular, this seems to really excel at large block sizes and for random reads. You can see that it's random read even in 4K is pretty performant. For example, let's take a look at 557 compared to the SAS-2 at 362. So that is a very significant performance advantage. And on random 4K writes, the SAS-2 drives had 148 and this has 414. So clearly the SAS-3 and this particular SSD combination provides a very significant performance advantage for this upgrade. All right, so let's go ahead and proceed to the next setup, which is going to be RAID-0 across all 8 SSDs, and then we'll repeat these tests and record the results. All right, we're going to create the RAID-0 as devmd0. We have 8 devices. We're going to use RAID-0, assume clean. This is drives SDC through SDJ. All right, so next let's make a file system. All right, and we're going to mount this under /data. All right, so we'll start with the DD test. I'm going to drop all the caches, and we'll repeat the DD test for the read. All right, let's go ahead and record this. All right, next, let's run the IO zone test. Now, since we have an aggregate RAID-0 of all 8 SSDs, in this case, I will use a larger data file for each thread. So I'll use a 1 gigabyte data file with 32 threads. That's going to be a 32 gigabyte data set. All right, so that went really fast. As you can see, we've got some enormous numbers here, over 5 gigabytes per second in aggregate. So let's go ahead and record these results here. All right, so let's repeat that test with 4K record sizes. All right, 4K test is complete. Let's go ahead and record this. All right, let's just take a quick look at the results with the 8 SSD in RAID-0. We got some very strong numbers. We're looking at sequential writes of over 5 gigabytes per second across the board for both sequential and random at 1 megabyte record sizes. When we go down to 4K, obviously this puts a much higher IOPS load, and so we're seeing slightly lower numbers, but still very impressive. We're looking at 1.6 gigabytes per second in 4K sequential writes, over 1 gigabyte per second on 4K sequential reads, and this seems to be consistent behavior. I think we're seeing, well, no, actually not. I was going to say that we're seeing some consistent behavior where the writes are stronger than the reads, but that's not necessarily the case. I was thinking back here on the DT test, but like again, I'm not going to really put too much thought into that. But okay, so random 4K writes and random 4K reads, also very strong results. We're looking at over 2 gigabytes per second in the 4K writes and over 1 gigabyte per second on the 4K random reads. So if we compare that to the last example, clearly there is a very significant performance boost in this SAS-3 upgrade. All right, so now let's go to the next setup, which is going to be a ZFS RAID-Z2 of those 8 SSDs, and then we'll run all those tests over again except for the random 4K reads and writes. Hey guys, so this is kind of unexpected, so I thought I'd just record this and share it with you guys. After that IOZone 4K random test on the RAID-0 set, the system, so that obviously completed, we recorded the results, but while I was recording the benchmark results, the system's spontaneously rebooted itself. I'm not really sure why yet. I just logged into the iDRAC and I'm seeing the CPU 4 M01 VDD-QPG voltage is out of range. I don't really know what that means, but it caused the system to basically spontaneously reboot itself. I'm looking at the lifecycle controller logs here, and yeah, you can see the system CPU resetting, and the system is now, I guess, booting up again. So I don't know if this is indicative of a problem with the processor or what, or kind of the general stability of this system in the setup. I wouldn't think that using the SAS-3 controller and the SAS-3 SSDs would have caused that type of error, but I just wanted to share this with you anyways because it did happen. So I'm going to let this system boot up. It does take quite a while for the system to boot up, so I'm going to let it boot up and log back in, and we'll set up again to continue the rest of the benchmarks. Alright guys, I got the system booted back up again, and everything appears to be normal, so I am not really sure. Even the MD stat here, yeah, so even the RAID-0 set is still there. So anyway, that's not going to do us any good at this point, so I'm going to go ahead and stop that one, and we're going to go ahead and create the ZFS RAID-Z pool now. Alright, so Z-pool create data RAID-Z2, and this is going to be SDC through SDJ. Oh. We'll force that. Okay, so we have our RAID-Z pool. I will create a data set under data/test, and so this is where we will run our benchmarks. All right, so let's start with the DD test. Let's see if I still have that saved. Looks like I do. All right, let's go. All right, I'm going to drop the caches, and then we'll repeat the read test. All right, so we got some pretty impressive numbers. All right, very impressive numbers indeed. Numbers that are greater than what we saw with the RAID-0. So, but again, this is why I think DD is not really a great benchmark, because you get these results that there might be something else going on there. But anyway, it does seem like the system is performing fairly well. So let's go ahead and run the IO zone test now. All right, so this is going to be the 1 megabyte record size IO zone test for sequential writes, reads, and random reads and writes with 32 threads and direct IO enabled with 1 gigabyte files per thread. So that's going to be a 32 gigabyte data set. All right, guys, the results are back, and this is incredible and probably not realistic, and I think I know why. All right, so you can see here that we have this ridiculous, I mean, wouldn't you be happy to see a benchmark score like that? I know I would be, but I just know this is not real. So those are in kilobytes, so we're looking at about 21 gigabytes per second. And yeah, that's incredible. But okay, so this is what I think happened. The system spontaneously rebooted, and I wasn't able to check the boot sequence at that time. And so it booted up with a full 1.5 terabytes of RAM. And so you can see ZFS makes very good use of that RAM to optimize your IO performance. And so we're getting some ridiculous numbers that I know the hardware is not even capable of doing this, other than the fact that this is probably going to RAM. So, okay, I'm going to go ahead. So scratch all this. I'm going to go ahead and reboot the system with mem equals 8G like I did in the previous video and in the previous boot up as well. So anyway, I just thought I'd share these numbers with you. They look fantastic. They're incredible. You'd probably get very excited about, but it's just not realistic. This is a lot of the RAM coming into play here. So that's not what we want to know about as far as the IO subsystem performance. So I'm going to go ahead and reboot the system, and I'll come back when I've got this booted up with only 8 gigs of RAM. All right, guys, I'm booted back up this time with mem equals 8G. So as you can see, there is now much less memory. And so if you recall what I said earlier, when we were running the DD test on the ZFS pool, I said, you know, those DD tests, I guess they're just not that reliable. Something else seems to be going on. Well, indeed, something else was going on. There was 1.5 terabytes of RAM. That's what was going on. So we've limited the amount of RAM that the system can see now. So hopefully we'll get more accurate and meaningful results here. But that certainly was exciting to see such numbers. But you know, it's just not realistic. So anyway, I'm going to repeat the DD test because that was run with the 1.5 terabytes of RAM as well. So, all right, so I've got this here. Let's go ahead and, all right, so let's rerun the DD sequential write test. Drop the caches. Redo the sequential read test. All right, so now we have, I think, results that are more in line to what I might expect. So, all right, let's get rid of the previous results, which was skewed by the 1.5 terabytes of RAM. All right, time to run the IO zone test. So this will be, again, with 32 threads, 1 gigabyte files each, so a total of 32 gigabyte data set with 1 megabyte records. All right, so the IO zone is completed. Let's go ahead and record these results. All right, next test is IO zone again, but with 4K record sizes, but we're gonna remove the random IO test here because just we already know that's going to perform horribly. So all right, so just 1 GB file sizes, 32 threads, so a 32 GB total data set, sequential reads, sequential writes with 4K record sizes. All right, guys, so there we have it. Those are the performance numbers with the SAS-3 upgrade. And clearly, if you compare the ZFS with RAID-0 results, clearly ZFS RAIDZ2 could maybe use some optimization to better take advantage of the hardware infrastructure that's here. But it is certainly capable of over 5 gigabytes per second in sequential or 1 megabyte record size transactions. And even at 4K, we're looking at over 1 gigabyte across the board and over 2 gigabytes in the random writes and sequential writes at about 1.6 gigabytes per second. So clearly the SAS-3 upgrade does give you a pretty significant performance boost. Again, if we can compare that to the previous numbers here, nothing here above in the 4K results with RAID-0, nothing above 1 gigabyte. And if you look at the 4K results for sequential writes and reads, we're talking about a gigabyte and 1.7 gigabyte there. So when we compare that, so those are similar, just slightly higher with this setup. That may be a result of, RAIDZ2 and ZFS just not as optimized for this. Like, we're not doing any tuning here, so we just took the default settings with the ZFS RAIDZ2. For 1 megabyte block sizes, we're seeing over 2 gigabytes per second in random reads, about 1.6 in random writes. Let's see how that compares to. So there's a pretty decent performance boost there from 1.6 to about 2 gigabytes there. So I think, if we were to do some tuning, I suspect that we can probably squeeze more performance out of the ZFS RAID-Z pool, because clearly the hardware is able to do quite a bit more. And I'm a little disappointed to see that the default kind of ZFS RAID-Z pool is so significantly behind the RAID-0 set. And I know the RAID-0 set has all 8 SSDs working together, while the RAIDZ2 set basically has 6 data disks and 2 parities, right, in the stripe. So, but still, this seems significantly below what the RAID-0 is, to the point where I kind of suspect that you probably could get a little bit more out of this. Like I said, we're just doing default settings here, so maybe with some tuning we could see some performance boosts. But compared to the SAS-2 setup, definitely we have a pretty significant performance boost across the board. And that may be a result. Now, keep in mind, we're not comparing the same SSDs, so we're really kind of overhauling the entire storage subsystem with the SAS-2 92078i with SAS-2 SSDs to these Hitachi SAS-3 SSDs with the 9300 LSI controller. So don't take these numbers as comparing, just the controllers, because it's basically the entire set has been changed out, right? The whole storage subsystem with the SSDs and the controller have been swapped out. So obviously your numbers could be very different if you pick SAS-3 SSDs that perhaps perform better or perform less. So those have to be taken into account. But I just wanted to give you guys a general idea of what you could kind of get with a SAS-3 upgrade of the R820. And again, remember, this type of upgrade also applies for the R720, so long as you have the right backplanes to do this. The next video will be the last and third part of the series of upgrading the storage in R820. It will also be an upgrade option that is relevant for the R720. That's going to involve an actual official upgrade, Dell upgrade option. So up until this point, we've been swapping out the HBA, the SAS storage controller from a RAID controller to an HBA, and that was not really a official Dell upgrade option. Today we're taking advantage of the direct attached backplane and upgrading the hardware to SAS-3, and again, that is not an official Dell upgrade option, so we're kind of deviating a little bit from factory options, but the next video will be an official Dell factory option that you could order with your R820 or R720 when they were brand new. But anyway, we're going to explore some of that. I'll describe all the parts that you need for that upgrade, but basically I'll give you a hint as to what that is. It is a 4-letter acronym that starts with the letter N as in Nancy. Stay tuned for the third part. I think you'll enjoy that. There will be the ultimate upgrade for the R820 and as well as the R720. Alright guys, so that's it for today's video. I hope you enjoyed it. I hope you liked it. There was an unexpected benchmark there that I thought was kind of amusing. When I saw it, I immediately knew, okay, this couldn't be right. But anyway, I wanted to share that with you guys, so I hope you enjoyed that. If you like this video, give me that thumbs up. And if you're new to the channel and you like this sort of stuff, be sure to subscribe to my channel. Also, if you want to support my channel, check out my eBay store. I'll leave a link in the description, video description below. Also, I will leave links to the HBA card that I used to upgrade the R820 in this video today. Alright guys, that's it for today's video. Hope you enjoyed it and have a great day. Bye-bye.